Today we'll talk about how to solve simultaneous equation. Simultaneous equation means like you have equation with two unknowns, maybe x and y. And to solve a simultaneous equation with two unknowns, you need two equations. So something like this. There are usually two ways to solve a simultaneous equation. The first way is called substitution, which you go to one of the equation and you make either one of the unknown the subject. Okay, so sometimes one of the unknown would be quite easy to make the subject, in this case y, because you can simply move the 2x to the right, then y is the subject. And then now you want to substitute this into the other equation. Alright, so you will substitute this to the y of the second equation. So we have 3x minus 2 times of y, but y is this now. Y is 5 minus 2x equal to 4. Then you'll get an equation of a single unknown, which you can solve like normal. After you solve for the first unknown, you want to substitute this back into the one where y was the subject. Then you can easily get y as well. So this is substitution. Then let's look at this example instead. Maybe for this one, it seems that it will be a tiny bit more difficult to do substitution, because no matter which one you choose, there is not an easy choice to make a subject. Right, you'll probably have to divide a number, which gives you a fraction, which technically still work. You can still substitute this to the other equation. But it will take a tiny bit longer to solve this. In case you're wondering, this is still doable. You can expand the number first, so it's minus 8. 3 times 8 is 24. 3 times 3 is 9. And then you can get rid of this denominator by multiplying the whole equation by 2. So 3x times 2 is 6x. And then you minus this 2 thing. And then negative, negative, positive. And then 3 times 2 is also 6. Then we get 15x equal to 30. So x is 2. Then similarly, you can substitute x back to the equation where y was the subject. So this method would still work, but it seems to be a tiny bit complicated. So there's actually an easier way, which is called elimination. Elimination is really fast when you already have one of the unknown having the same coefficient. The coefficient is the number in front of the unknown. So here we have 3 for x and also 3 for x for the other equation. So now they have the same coefficient. That elimination would be very nice. You do it by subtracting one equation from the other. Okay, but we'll subtract vertically. So we have 3x minus 2x, which gives 0x, so that's just 0. And then we have 2y minus negative 3y. So this is where you have to be careful with the sign. So 2y minus negative 3y is the same as 2y plus 3y. So it's 5y. And then 8 minus 3 is just 5. So y is 1. After you know y, you can substitute y back into either one equation. Doesn't matter which one you choose. And so 3x is 6, x is 2. So elimination is usually faster. So let's try another one. Now this time the coefficients of x are different, but the coefficient of y is the same. So we can still do elimination. We can try to eliminate y. Now, but the interesting thing is the sign before y is different. This is a plus, but this is a minus. In this case, when you try to eliminate, you don't want to subtract. You want to add them instead. Now, the reason being, if you have positive 3y, and then you add to negative 3y, then that would give you 0y. Okay, and we want 0, because we want one of the unknown to be gone. Then we can add the other stuff. 2x plus 3x is 5x. 7 plus 3 is 10, so x is 2. Okay, by now you probably realize the answer are all the same in all my examples. But yeah, it doesn't matter. Just want to teach you the method. So we substitute back x being 2 to the first equation to solve for the other unknown. Now, very lastly, it is possible that you will see a question where none of the coefficients are the same. All right, so here x have different coefficient, y also have different coefficient. So it seems like both elimination and substitution are not like the easiest to do. In this case, I would still recommend doing elimination. Now, if they don't already have the same coefficient, it is possible to make them the same. So for example, I can make 2 and 3 into the same number by multiplying each equation into the lowest common multiple of those two numbers. Okay, well, what I mean is this. If you think about this, if you multiply 2 by 3, it will be 6. But if you multiply 3 by 2, it would also be 6. So by multiplying each equation by some number, it is possible to make the coefficient of both of the x the same. So that's what we'll do. We'll multiply the first equation by 3, multiply the second equation by 2. Okay, so we have 6x plus. Now the key is remember to multiply everything in the equation by the same number. Okay, so the first equation we are multiplying by 3. So multiply this by 3, we get 9y. 7 by 3 is 21. And then for the second equation, we'll multiply by 2. So 6x minus 4y equal to 8. Now the coefficient of x are the same. Both of them are positive, so we will minus this time. So 6x minus 6x is 0. 9y minus negative 4y. 21 minus 8. And then same as before, we will substitute y back into one of the equation. Maybe the first one. Then again, you will find x. So this is how you do elimination. Obviously, you want to practice a little bit. If you want to find suitable exercise from me, you can join the membership. Then you'll find appropriate exercise on this.